In this video, we'll be doing some problems that involve the Fundamental Theorem of Calculus. The theorem says, if f is continuous on the closed interval from a to b, and capital F is an indefinite integral, or an antiderivative, then the definite integral from a to b of f of x dx is equal to the indefinite integral evaluated at the right endpoint minus the indefinite integral evaluated at the left endpoint. Our first example, evaluate the definite integral from 1 to 2 of the function x squared minus 3 dx. The first thing we want to do is integrate and then write that as shown. So the integral of x squared, remember we'll just use the power rule. So increase the exponent and divide by the new exponent. So we have x cubed divided by 3 minus, and then on this one, remember you can think of this as 3 times x to the 0. So increase the exponent, divide by the new exponent, and that's going to be minus 3x. And we show that now when we use the Fundamental Theorem of Calculus within brackets, and our lower limit of integration is written here at the bottom of the bracket, and our upper limit of integration is written at the top. Next, we want to evaluate at each of those. So we first put in 2 for x, and we have 2 cubed divided by 3 minus 3 times 2. And then we subtract from that expression evaluated when x equals 1. So 1 cubed divided by 3 minus 3 times 1. Simplify, and we get 8 divided by 3 minus 6 minus 1/3 plus 3. Do the math, and we find that the integral from 1 to 2 of x squared minus 3 dx is negative 2/3. Our next example, we want to evaluate the integral from 1 to 4 of 3 times the square root of x dx. Again, we're going to integrate and write it in brackets. We did a rewrite and pulled our 3 out in front of the integral, and then wrote our square root of x as x to the 1/2 power. So when we integrate that, we get x to the 3/2 divided by 3/2. And again, remember on the brackets you write your lower limit of integration at the bottom and your upper limit at the top. Let's simplify that complex fraction. So dividing by 3/2 is the same as multiplying by 2/3. Now use our Fundamental Theorem of Calculus. Evaluate this expression when x equals 4. Notice that I canceled the 3's. So I just have 2 times 4 to the 3/2 power minus, and then 2 times 1 to the 3/2 power, which is just 1. Now 4 to the 3/2 power, if we do the half part first, that's the square root of 4, which is 2, and then 2 cubed is 8. So I have 2 times 8 minus 2 times 1, which is 14. And then our last example, we're asked to evaluate the integral from 0 to pi over 4 of secant squared x dx. Integrate and write it in brackets. So the integral of secant squared is tangent x, and we're evaluating that from 0 to pi over 4. The Fundamental Theorem of Calculus says that I'll evaluate that tangent x when x equal pi over 4, and then subtract from that the tangent of 0. The tangent of pi over 4 is 1. The tangent of 0 is 0. So that integral is equal to 1.